Okay, I try to build everything I can as a module for exactly that reason. All right. Now, there's another major understanding that you have to have of modules is that in PureBasic, modules are sealed. Nothing, nothing can come into or be referenced inside a module that does not exist in the module. So that is why when we defined let's come back to our global variable here. We defined, that's where he is. Okay, that's these guys. All right, we'll bring it up again. I must have accidentally closed it. Okay, so here I define a global variable. Now, the basic definition of global means every sheet, every procedure throughout my entire app, everybody can see the current singular instance of work sprite sheet. That is a true sentence, except where modules are concerned. A module cannot see anything that is not inside this declare module. Okay? He can't see it. So I cannot reference that global value here. Everything that a module is exists into himself. So that's why we have to pass a reference to a global variable or object into the module so the module can mess with it. So there's a few penalties that come along with that, but that's one of the also things that makes this pretty awesome. Okay. If you look closer at modules, you'll see you got two definitional declare areas. Okay. On the declare module side, these declares are all public. So anywhere in your application, I can reference this sprite sheet declare module, and I can see all of these. This is your type ahead, your little pop-up that says, oh, you want that? Here's what you can see in that. Okay, that's these guys. Down here, once you're inside the module, these declares are all private. Nobody external to the module itself can see or call these functions, which is, again, a huge, powerful thing. We don't want people calling a load SS tile collection or a save SS tile collection outside of the public ways you can do that. And the only way you can do that is by coming up here and doing a find or save. That way, we force you to come through the two validate steps, okay, or the delete. Okay, so that is some of the really neat stuff about modules. That is some of the really neat stuff about PureBasic. So now I would like to show you how easy it is to create a memory leak and not think about it. It looks right off the cuff, and it's not. So what we have, what we're looking at here, is the set screen function of the parent form sprite sheet. And you can see we're loading the tile collection onto the list of list icon tiles on the screen. We've passed a reference to our global work sprite sheet that we're using in this app, and everybody's happy. So that makes lots of sense to everybody. And then I build this other function, and we come in and say, I want to iterate my global variable. So I have this global variable, right? He is visible to everything and everybody. So I come in here and say, okay, work sprite sheet, let's iterate your collection. And I want to change everybody's name to George. Now, all of our code should one of the first sentences in all your apps should be enable explicit. Now, one of the nice things that that does is it forces us to not be lazy. All right. If you don't have that turned on, then this code will work just as it is. But with that turned on, you at least get a reminder that says, hey, you have not defined child. Child is an undefined object. So you're trying to create a child object and set him equal to the object that's in the list. So if I don't have explicit on, this code would run. He would create child. It would be a clone of this guy. He would then change the clone's name to George, and this would run, and I would look at my data and go, why didn't everybody go to George? Well, I didn't change my data. I changed this new created child, his version of that guy, and I created a memory leak because if you notice, we're in a for each instance, a for next of all the records that are on the tile in the sprite sheet itself, okay, in the collection. So if there were 5 records here, I now have 5 copies of him in memory because every time he passed through here, he created a new record. So a real quick thought would be to come up here to fix this, would be to say, okay, let's set child up. CHILD, and he's going to be an SS tile and SS tile. Okay, so now I got a variable up there. Great. So now we set my instance of child equal to the instance of tile that is in the collection. Once again, I've created a new instance of that particular record. I am not playing with the SS tile collections version of the record. I created a new one right here with this definition. The right way to do this is going to be to create a pointer. So you have a pointer here that is saying, I want this to be pointed at something that is a SS tile type class. So here, if we change this to being a star child, we could then come over here and this would be child equals he becomes a pointer to this specific record, which is selected by the sentence above. So now he takes on the clone. Well, it's not a clone. He becomes the pointer to this. So we have a second guy here who is him. So I now can change my pointer, his copy name, and physically I'm changing this guy. Does that make sense to everybody? Do you see how that works? So I created a pointer and then I put the value of the pointer to equal the same value of the instance of this one record, this one object in memory. So now when I use this, I am actually using this because they are equal. And so when I change the name here, when this code now executes, it now updates all SS tile collection records for this sprite sheet to be George. Okay, so that is now the new thinking that you have to understand all of this. Okay, and this works for modules. This works for any gadget in the whole system. Heck, it'll even work for the Windows themselves. It's a very powerful feature, and it's an awful lot to wrap your head around. Now, I want to point out that this isn't unique to PureBasic. It isn't unique. It isn't every every significant language on the planet, C Sharp, Visual Basic, Java, doesn't matter who they are, C, they all have a similar concept of this. You have pointers that you point to specific objects in memory, and then you play with pointers. That way you're not creating lots of new stuff, you're actually reusing what's there. So it's a big array kind of thing. But anyhow, that concludes the understanding of objects. Let's go back to my list here. I wanted to make sure I covered enumerators, objects, references to objects, passing a reference, pointers, using the syntax of ampersand, which we actually do up here to pass the pointer to the object that exists, that we have instantiated back on the first code sheet. So that's how all of this ties together. And it's an awful lot if you're new to a language or new to programming. It is a quite big element to swallow. So maybe you watch this once or twice just to get a good handle on it and then go look at other code. So that's it for this video. Thank you.